Okay, hello everyone. Today we are going to learn about the second material of our course, uh, Information and Security Assurance. So I will share my screen. Okay, so this is the material for today. So we are going to talk about introduction of cryptography. Yeah. So today we are going to talk about introduction of cryptography. So, well, as you can see in here, yeah, cryptography is actually came from the ancient Greek language. Start from cryptos, which mean hidden or secret, and graphein, which mean to write, and logia, yeah, which means study. Yeah, so respectively, cryptology means studying how to write hidden or secret message. Yeah. So cryptology is the practice and study of techniques for data encryption and decryption. So learning about cryptology, it means we study about several techniques to encrypt and decrypt data. So cryptography is a field of computer science and mathematics. So it is not about computer science only. It also mathematics inside it that focuses on techniques to secure communication between two parties while there is a third party present. Yeah. This is based on methods like encryption, decryption, signing, generating of pseudo-random numbers, etc. Yeah, so cryptography, it means how we study about how to uh, deliver data, yeah, how to send data between two parties from A to B, let's say. Well, while there are some third party present, yeah, the third party is unauthorized party. Yeah. If we look at the history of cryptography, the history of cryptography start from the Kaiser shift chipper. So one of the most famous crypto system goes back to the cryptography used by Julius Caesar. Yeah. Uh, the uh, the person from Romawi era. Yeah. So the Caesar zipper is named after Julius Caesar. Used it with a shift of three. Yeah. For example, alphabet A become D when we encrypt the data, and D alphabet become A alphabet when we are doing decryption. So why Julius Caesar do this? Yeah, the reason is to protect messages of military significance. So if you look at this formula, yeah, so the encryption, let's say the encryption is X in here. So it comes X plus K. Yeah, what is K? K is the number of shift. Yeah, for example, if we look at the Caesar shipper, the default is 3, yeah, because Julius Caesar is using the shift of 3, yeah. A become D, A, B, C, D, yeah. 3 alphabet after A is B, C, D, yeah. So D is the crypted, yeah. And D become A, yeah, when decrypting, yeah. Decrypting is the opposite of encrypting. So it means from the cheaper text back to the plain text. Yeah. So in the encryption formula, X taken from X plus key, the number of shift, modulo 26. Yeah. And in the decryption, Y minus key modulo 26. So this is the basic formula of Caesar shift cheaper. And this is another example, yeah. For example, the simplest monoalphabetic cheaper is the additive cheaper. So this cheaper is sometimes called shift cheaper, yeah. So Caesar cheaper is also known as the Swift cheaper, but the term additive cheaper better reveals its mathematical nature, yeah, because additive it means we increase something, right? For example, plain text is A, and this is the value, yeah, it's like our alphabetical order from A to Z, start from 0 to 25. And this is the Caesar Safe Cheaper implementation, how it works, yeah. For example, Alice want to deliver secret message to Bob, yeah. So, for example, the plain text of Alice message is P, alphabet P, yeah. So, the cheaper text is P plus K. So, K is the addition, the number to be added, yeah. For example, it is 3, so P plus K modulo 26. So if we back in here, P in here, yeah, 15 plus 3, it will be, if the key is 3, then the result of the encryption will be S, yeah. Yeah. So the plain text is encrypted here and it becomes cheaper text, and the cheaper text is delivered to Bob. Yeah. When Bob do decryption, yeah, it use the decryption formula. So C it means the cheaper text. Yeah, P is the plain text. Plain text, how to decrypt the cheaper text into plain text? Bob will use this formula. Cheaper text minus key, yeah, the key itself, yeah, the number of a shift, the number of shift, yeah, C minus K modulo 26. So Bob can get the plain text result. Yeah, for example, this one, yeah, B, if we are using three number shift, yeah, B becomes, when the plain text is B, then the encrypted result will be A, yeah. A become D, yeah, C become F, and so on, yeah. The decryption is the opposite of encryption. So if we have D in the cheaper text, so when it got decrypted, it becomes A. Yeah. So for example, this one, we have a plain text, Internet Society Ghana chapter. This is the plain text. Yeah. For example, A in here, A it should become H, yeah, because it increased three, yeah, A, F, G, H, yeah. So the cheaper text here, you can look at this one. So E become H, yeah. So this is the cheaper text. What is the cheaper text? Yeah, cheaper text is the result of encryption. Okay, so for example, if we use the additive cheaper with key 15 to encrypt the message hello, yeah, so we can look at the process in here. So we split the alphabetical order here, like the first plain text is H, the second plain text is E, the third plain text is L, the fourth is also L, and the fifth is O. Yeah, so if we encode all of this alphabet into number. So the value of H is 7, the value of E is 4, the value of L is 11, and the value of O is 14. Yeah. And if we use the encryption formula, so we gonna put 7 in this P, yeah, so the plain text is 7. And since we are using key 15, so we increase 7 with 15. So the result will be 22, right? 22 modulo 26, since 22 is lesser than 26, so the result of the modulo will be um, 0, yeah. So 7 to 15, yeah, modulo 26, the cheaper tax is uh, 22, yeah. So oh sorry, it's not 0, yeah, when the number here is lesser than the number to be modulo with, so the number is stay the same, yeah. So 7 plus 15 equals 22. 22 modulo 26 is equal 22, yeah. So the result of encryption is 22. So what is alphabet that has value 22? So if we look at this one, 22, it means W, yeah. So the result of this encryption, yeah, from H, when it finished encrypted, the result will be 22 or W, yeah. It also implemented the same way, the same method for the E, L, L, and O. Yeah. For example, in this one, E is 4, so we add 4 with the additive cheaper key 15. Yeah, 4 plus 15 equals 19. Since 19 is lesser than 26, so it stay the same. Yeah. So the result of encryption is 19. So what is the alphabetical order that has value 19? So if we look at this table, 19 is T. Yeah. So the encrypted result of plain text E is T. Yeah. And it also done the same for L and O. It is done sequentially until every alphabet in the word hello, in the message hello, all finished encrypted. Yeah, for example, so hello here is the encryption result of hello world in here is the cheaper the hello word here is the W TAAD, yeah. So when we try to do the decryption, so we are implementing the opposite formula. So we are using the decryption formula. So if we use the additive cheaper key 15 to decrypt the message WTAAD, so it comes like this one. So the cheaper text is W, which value is 22, and we put the cheaper text value into the decryption formula. 22 minus 15 modulo 26, so it goes 7, yeah. Since 7 is lesser than 26, so it remains the same, yeah. So plain text that has value 7, yeah. If we look at this table, 7 goes to H, yeah. So 7 is H, so that's why it is H, yeah. And when we do the decryption to the other cheaper text, so we will get hello for the result of the decryption, yeah. So this is the Kaiser shift cheaper, yeah. And the second cheaper is Fijianeer's cheaper. Yeah. So this is the generalization of Caesar's cheaper. Yeah, and it was invented several times. Nowadays, the reference goes back to the French cryptographer Blaise de Figenaire. Yeah. So the main difference compared to the Caesar cheaper is that instead of using only one key, so they are using more than one key. Yeah, for example, let the secret be represented by the word key. Yeah, so the secret is key. So we again map the letter from the alphabet to corresponding number modulo 26. So the key is not only one, but it has three key. Yeah, how to implement it? Let's see in this example after this. Yeah. For example, if we want to encrypt the message C is listening using the 6-character keyword Pascal, so Pascal is the key, yeah. So we got the key stream P, yeah. If we look at the table in here, P is 15, yeah, and A is 0, S is 18, and then C is 2, A is also 0, and L is 11. So the code of Pascal is 15, 0, 18, 2, 0, 11. So if we translate it into alphabetical order, we will got Pascal in here, yeah. Pascal, yeah. And our plain text is she is listening. So she is listening in here. It goes for the plain text. And if we translate the plain text into P's values, S is equal 18, H is equal 7, A is equal 4, I is equal 8, S is equal 18, L is equal 11, and so on until every alphabet, every character in the sentence converted into piece values. And the key stream is using Pascal. Since we are using Pascal, Pascal consists of 3 characters. So it means we need to split, yeah. We need to split the message into several sections. Each section consists of 5 characters. Why it consists of 5 characters? Because the key limited to 5, yeah. Since the key length is 5 character, PASCAL, yeah. So the plain text must be split into several sections, yeah. Each section has 5 character. SHAISL, it's 5. So this is the first section. Then the second section, ISTENI. This is the second section. And NG is the last part. Not the length of the character is not 5, but it is okay. Yeah. So since it's just 2 character NNG, so it is just using P and A. Yeah. SCAL is not used. So it's only 15 and 0. But for she is L and istani, it using the Pascal codes. So 15 is P, 0 is A, S is 18, 2 is C, 0 is A, and then 11 is L. Yeah. It is used again in the second section here, 15, 0, 18, 2, 0, 11. And then after that, each plain text, which already turned into the piece values, is encrypted into C's values. Yeah, using the same formula. Yeah, it's like 18 plus 15 modulo 26. So 18 plus the key is 15, yeah. 18 plus 15 modulo 26 equals 7, yeah. 7 plus 0 modulo 26, since 7 is lesser than 26, it stay the same, 7, yeah. 4 plus 18, it's 22 modulo 26, 22 is lesser than 26, so the C's value stay the same. 8 plus 2 is 10, so stay the same. 18 plus 0 is 18. 11 plus 11 equal 22. 22 modulo 26 equal 22. So this is the cheaper text. Yeah, so as plain text, as when it's encrypted, it becomes H. And H in here, when it's cheaper, yeah, it become H also. Yeah, the same H, but the piece values is different and the key stream is also different. But if you look at the cheapest value is actually the same, but it comes from different piece value and key stream. So the piece value and key stream uh, is is deciding the result of C. Yeah. So this is the Fijian receiver, yeah. So the initial key stream is 15, 0, 18, 2, 0, 11. It comes from Pascal in here, yeah. Pascal, if we translate into value, it will become 15, 0, 18, 2, 0, 11. And after that, we just need to implement the encryption formula and decryption formula to encrypt the CS listening words into cheaper text. Yeah, the plain text into cheaper text. So this is the progress. Yeah, so she is listening. First, we need to split the whole plain text into several sections with the equal length of the key. Yeah, if we are using Pascal key, so it means Pascal consists of 5 character. So we need to split the plain text into several sections. Each section consists of 5 character also. So she is L, it's 5. Yeah, Istani is also 5, and G is only 2. It's okay if it is not reaching 5 in length, as long as it's still word left in here that's still not processed. So we can also uh, make it to another section. Yeah. So the first section is S. Yeah, S is the first word. I is also the first word, and N is also the first word of the section. Yeah. So this one SIN. S is decrypted, is encrypted into H. Yeah, and then H in here decrypted into H. Yeah, because we are using Pascal, so it is staying the same. Yeah, it's not encrypted, it's still the same. And A, E in here is encrypted in this process. E become W, and we also have T character in here, which is in the third position. T is um, uh, encrypted into L. Yeah. So the final result become HHW, KSW, XS, LG, and PCG. So it is meaningless and doesn't even have any meaning at all. Yeah. It is a random word. Yeah. If you look at the plain text, from she is listening become double HHWKSW, it is of meaningless. Yeah. And it means we can deliver this message securely, even if there is a third party that can eavesdrop our data. And the third cryptography is Diffie-Hellman K exchange. Yeah, Alice chooses A, Bob chooses B. So each user has their own key. So in 1976, Whitfield Diffie and Martin Hellman, also Ralph Merkle, proposed an idea for securely exchanging keys over an insecure communication channel. Nowadays, the encryption method known as the Diffie-Hellman key exchange. How it works, you can look at this image here. I prefer to explain the image on the right here. So, for example, yeah, both Alice and Bob, yeah, they need to agree upon several things. The first one is they agree that the prime number that will be used is 13, and the generator of P is 6. Yeah, so the P and G is the variable needed to process the Diffie-Hellman key exchange in here. And Alice has her own private keys, and Bob also has her own private number in here, private key in here. So the private key is actually randomly generated. Yeah, so it is generated randomly. So Alice randomly generated 5. Bob is randomly generated 4 as a private key. And then uh, the next thing to do is calculate the public key using G powered private, yeah, modulo P. Yeah, so the prime number is 13 and the G generator of P is 6. So it is G powered by private modulo P. For example, this one, since the generator of P or the G value itself is 6, yeah, and the private key of Alice is 5, so it becomes 6 powered by 5 modulo 13. Yeah, since they are agree on using 13 prime number. Yeah. So the result is 7,776 modulo 13. So it goes the public equal to, yeah, so the result of this modulo become the public key. And Bob also calculate the public key. 6 powered by 4 modulo 13 equals 1,296 modulo 13. So the public key of Bob is 9. So each of them, both Alice and SpongeBob, yeah, the Bob, yeah, exchange their public keys. Yeah, Alice share its her public key to Bob. Bob share his public key to Alice. And after Alice and Bob receive their key each other, yeah, so they start to calculate the shared secret, yeah, to decrypt, yeah. How to decrypt it? They are using this shared public powered by private modulo P. Yeah, so the shared public of SpongeBob here is 9, so 9 powered by 5. So what is 5 in here? 5 is it's on the private the private key of Alice, yeah. So 9 powered by 5 modulo 13 equal 59,049, yeah, modulo 13. So the shared secret is 3, yeah. So the message is 3. And um and Bob here also calculate the shared secret. So 2 powered by 4 modulo 13 equals 16 modulo 13. And the shared secret is also the same, 3. Yeah. So the encrypted message is different, but the plain text is actually the same. Yeah. The plain text is 3. Yeah. And the basic idea of cryptography is this one. Yeah, if you look at this image, yeah, Alice want to deliver secret data to Bob. Yeah, but as you already know that between Alice and Bob there is an insecure channel, which is in this insecure channel it could be several attackers, several eavesdropper. Yeah, let's say even Mallory here is Eve or Mallory, yeah, Eve is adversary, so it takes other identity, yeah, in order to attack or eavesdrop the data, and that is delivered through the insecure channel. So Alice need to secure it plain text so it can be delivered into Bob through this insecure channel without worrying of being attacked or eavesdropped. Yeah, how to do it? We need to use cryptography. Yeah, we need to employ cryptography. So if we employ the cryptography, so the plain text that will be delivered by Alice to Bob will be encrypted into meaningless data, yeah, that cannot be eavesdropped. Yeah, even if it is eavesdropped, Eve or Mallory cannot understand, yeah, the data. Yeah, so Eve or Mallory only receive the cheaper data. Yeah, so it's not so Eve or Mallory not getting the plain text. Yeah. So the principle of cryptography consists of the confidentiality. So it defines a set of rules that limit access or add restriction on certain information. So first we need to make sure that our data, our information is restricted. Only authorized user can access our data. And then we need to make sure the data integrity, take care of the consistency and accuracy of data during its entire life cycle. And we need to make sure about the authentication. We need to confirm the truth of an attribute of a datum. Yeah, it's data that is claimed to be true by some entity. We need to make sure, yeah, that the data is authentic, not modified. It is original. Yeah, and also non-repudiation. Yeah, we need to ensure the inability of an author of a statement response piece of information to deny it. Yeah. So for example, I cannot deny that I am the sender. Yeah, so that's need to be concerned when we deliver data securely. Yeah. So data type, yeah, data on transmitting. When we talk about data, data is actually divided to several kind of data. Yeah, for example, the signal transmitted from phone's conversation is actually a data. Yeah, ATM PIN number transmitted from ATM to the bank server. It's actually data transmission credit card PIN number for e-commerce transaction by internet banking is also transmission of data. Message with chat media such as WhatsApp, Line, BBM, it's also transmission of data. Data on end system could be text, yeah, and also could be multimedia data, could be picture, video, audio, or even the database itself. So the basic term, yeah, when we talk about cryptography, there are several terms that you're probably going to find in this study. First is the plain text. So what is plain text? Yeah, plain text is the original message. And the second is cheaper text. What is cheaper text? Cheaper text is the coded message or the result of the encryption. And cheaper is the algorithm or method used to transform plain text into cheaper text. Key is the info used in the cheaper, yeah, the info that used in the cheaper progress that is unknown only by the sender or receiver. And cheaper, also known as the encrypting. So it means converting from plain text to cheaper text. The cheaper, it's the other meaning, yeah. Or we also uh, identify the cheaper with decrypt, which means we need to recover. We are recovering from cheaper text uh, to plain text, yeah. So it's decrypting. We convert, yeah, we recover, yeah, the plain text from cheaper text. So the criteria, total number of key being used in cryptography, it could be only one key. Yeah, for example, in Cesar algorithm, the first one, the simplest one is using only one key. And Diffie-Hellman is using two key or even not using any key. Yeah. Later, we are going to talk about several cryptography type. Yeah. And the type of cheaper, it could use the substitution or transportation or product. Yeah. And the criteria based on the process of plain text, it consists of the block cheaper and the stream cheaper. Types of cryptography are three. The first one is symmetric cryptography, so also known as the secret key cryptography. The second is asymmetric cryptography, or also known as the public key cryptography. And the third type is hash function. So we are going to talk about the three of them one by one here. First, here is the symmetric cryptography. As you can look at this one, it is using a single key for encryption or decryption. So the secret key, when used in the encryption process, is actually the same key that used in the decryption process here. So the secret key in the encryption and decryption is actually the same key. So they are using single key. This is symmetric, yeah. And the plain text and the cheaper text having the same size. Yeah, the second characteristic of symmetric cryptography is the size of plain text is actually the same as the cheaper text. So between the cheaper text and the plain text, it has the same size. So those are the characteristicity of symmetric cryptography. So here, two requirements for secure use of symmetric encryption. The first one is strong encryption algorithm. The second is secret key known only to sender or receiver. In other words, you must make sure that the secret key is only known by you and your respondent. So you need to make sure that nobody else understand or know the secret key. And C is the cheaper text, P is the plain text here, and the encryption formula goes to right one. A encryption from plain text to cheaper text. So we encrypt the P, so the result of encryption of P is known as the cheaper text. And the decryption D, it means we are recovering from cheaper text to plain text. Yeah, so the decryption of ciphertext, it will resulting the plain text itself. Yeah, so the function here is like this one, DEP. The decryption of the result of encryption of P is the P itself. Yeah. So we assume encryption algorithm is known or public, therefore implies a secure channel to distribute key. Yeah. So this one, the figure that show you how symmetric cryptography being used. So let's say here, Bob want to deliver data to Alice. Yeah, the key used to encrypt and decrypt is K1. Yeah, so they are using K1 here. And the message from Bob to Alice or vice versa is delivered through insecure channel in this area. So this is the encrypted message. If is let's say if is the eavesdropper, yeah, that want to eavesdrop the data, and by using the secret key K1, they can deliver the data through the insecure channel without worrying of if being of if modify the data or attack the data. So for example, this one is the example of symmetric cryptography. So we attack it down. This is the plain text, and here is the key K. So the encryption, it goes from the AK encryption using K of P resulting C. So the C result is SORX GS P LVN WK. It's meaningless. Yeah. So cheaper text is meaningless. And then the cheaper text will be decrypted using the same key, and the decryption result of this process will be back to the plain text. Yeah, so it will be translated into we attack it down. So there are several methods in symmetric cryptography. DES, yeah, data encryption standard, AES, Ringdale, Blowfish, IDEA, Ghost, Serpent, SE2, SE4, and SE5. Yeah. And probably you can look for more method by Googling it yourself. Yeah. You can explore it by yourself, yeah, to look for more symmetric cryptography method. And as you can look at this one, this is the DES library. You can try to run this one into C Sharp. Yeah, I will give you a simple example. So for example, we're gonna try this one. You can use your favorite IDE. For me, I am using my favorite IDE, Visual Studio Code. Yeah, so I will make a new file, and I will select the .NET Network C# Dev Kit here, and I will make a simple console app. I will store it into the desktop. Yeah, for example, I will name the project with DES. Yeah, DES, since we are trying to um, make this DES library in C#. So let's wait and let's open the project, open folder. It is in desktop, DES here. We can select this. So this is the DES. The DES is opened in here. So let's wait. Yeah, since I am using the C#, yeah, let's wait for C# to prepare my project first. Okay, so let's wait. Okay, I will try to reopen my project in here. So the project is not even here. Maybe I will try to remake the project, yeah. C Sharp development kit. This is going to be console app. Discovering it said, I don't know. Probably there's a problem with my network or something. Let's just retry the process. Okay then. So we're gonna make this to um this one. So we make the SLN and then we create the project, yeah. So we create the project. This one. This is my project. So the console app one and the SLN in here. So we can try to build the simple C# program in the program.js. So I will delete this one. So let's try to make the DES library C#. So we're gonna copy the important library in here. And then we can try to make a class, let's say DES, yeah. So this one, and we are going to use all of this method provided in here. Okay, let's just copy it. This is the function to encrypt data, yeah. So this is implementing the encryption of data. And then we're gonna add the decryption. So the decryption function in here. So we're gonna add into our class. So I'm entering this one in here. Okay, so now we have the decrypt data function also. And then the last one, we're gonna add this public static void main. Yeah, this is the core of our application here. As you already learned in the OOP and algorithm programming course. Okay, let's start. Since this is just console apps, yeah, so the encrypted and decrypted result will be shown in the output terminal later. So let's run the program first. Okay, so this is the terminal. It said that it is building the project. Extension build result service is available. It said, let's wait for the result. Okay, so this is all right. So this is the program. So as you can see in here, the encrypted is this one. This is the cheaper text, and this is the result of the plain text here. So the plain text is ISA course. The key used for this DES is 1, 2, 3, 4, 5, 6, 7, 8, and the encrypted result is like this one. So it's meaningless, yeah. From this one, the attacker or the eavesdropper will have a lot of difficulties on trying to decipher this data, yeah, this cheaper text. Okay, let's back to our slide PPT. So this is the next cryptography. It means the asymmetric. The characteristicity of asymmetric cryptography is the key used in the encryption and the key that used in the decryption process is actually different keys. Yeah, that's the first characteristic. And the second, the encryption key can be made public. So the encryption key here is public, but the decryption is secret. The decryption key is not shared, but the public key is actually shared, yeah, made for public. Public can use it, but they cannot decipher or decrypt the cheaper text into plain text. Why? Because they are using two keys, public key and secret key. Yeah. If the attacker only has the public key and doesn't understand the secret key, so the cheaper text cannot be decrypted. Yeah. So the attacker must have uh, the public key and the secret key at the same time, yeah, in order to decrypt the cheaper text and recover it into the plain text. So this is the asymmetric key cryptography. Encryption key is different than the decryption key. Yeah. So encryption key is not the same as the decryption key. Yeah. For example, we have the plain text P in here, and we got the public key K1, for example, and the private key is K2. The encryption goes here, and it resulting cheaper text. And the cheaper text, when we try to decrypt it, it comes to the plain text. Yeah. So it is needing uh, two keys. Yeah, the public one and the private one. Yeah, for example, like this one, when Bob is trying to deliver data to Alice, yeah, Bob give the public key, yeah, from Alice, yeah, and Bob is sending data, and the data is delivered through the insecure channel in here, and if the eavesdropper or the attacker, if understand the public key from Alice, but if still cannot decrypt the message. Why? Because if doesn't have the private key from Alice. Yeah. So if the private key in Alice here uh, is not delivered to if, yeah, if doesn't know the private key of Alice, so the message still cannot be decrypted. In order to decrypt the message, if must have the public key and the secret key. So there are several methods in asymmetric cryptography. Yeah, for example, RSA, Reverse Shamir Edelman, El Gamal, Rabin, Diffie-Hellman. Yeah, Diffie-Hellman is actually asymmetric. So that's quite an example. Yeah, if you want to learn more. And also DSA, the digital signature algorithm. And this is the RSA library C#. Yeah, you can try to implement this code in your Visual Studio. Yeah, later you can try it by yourself. Yeah, just like the previous one. Yeah, you just need to copy the program on the C#, and you can try to run the programming. And the third type of cryptography is hash function, which is a mathematical transformation that takes a message of arbitrary length and computes it a fixed length short number. So the properties, let the hash of message is in m variable, and the hash function is h of m. Yeah, h is actually the hash function. For any m, it is relatively easy to compute hm. Yeah, it is very easy to compute the hash function because it is employing a mathematical transformation. And if we have hm, there is no way to find an m. Yeah, it is impossible to reverse decrypt. Yeah, to decrypt the hash message into into plain text. Yeah, because uh, hash is one way. Yeah, is one way encryption. It can be encrypted but cannot be decrypted. Yeah. And it is computationally impossible to find two values that hash to the same thing. Yeah. If we have, it is very, very hard to find two different words that has the same, has the same hash value. Yeah. So let's say if we have A and B, yeah, A and B, when it encrypted using hash function, the result of the hash function will never be the same. Yeah, it will be different. So let's this one is the password hashing. So system store a hash of the password, not the plain text. Yeah, not the password itself. So when the password is supplied, it computes the password hash. So when the message enter to the system will enter the message into hash function, and it will be automatically encrypted. And after it encrypted, it cannot be reverted into the plain text anymore because hash function is one-way encryption. Yeah, you can only encrypt it, but you will never decrypt it. Okay, then This is one of hashing cryptography, yeah. SHA-256, the library in C Sharp. You can try to use this program, yeah, in order to visualize or maybe to try, yeah, how hash function works. Next, we are going to talk about cryptanalysis, which means we study about attack that comes to insecure channel when we transmit data to our recipients. So eavesdropper is the person who get the messages transmitted illegally. The other name of eavesdropper can be enemy, adversary, intruder, interceptor, bad guy, and several names, several other names. Yeah, Ron Rivers say cryptography is about communication in the presence of adversary. So we can communicate each other without having any worries, even if in the presence of lot of adversaries. Yeah. Cheaper text only attack. Yeah. COA. Yeah. So this one is quite unique. Yeah. The cheaper text only. So let's say Alice is trying to deliver message to Bob, yeah. So when Alice deliver the message to Bob, Alice employ cryptography and turn the message into cheaper text if receive the cheaper text, yeah. So if got the cheaper text and if try to do some cryptanalysis in order to recover the cheaper text into plain text. So this is the cheaper text only attack. So the attacker have only has the cheaper text. And non-plain text, this one is actually Alice deliver cheaper text to Bob, and if know the cheaper text, and if also know the plain text. So what if do in this part is try to look for the cryptanalysis, look for the secret key. So what is the secret key? I have if say it's like if say that I have the cheaper text already and I have the plain text. So what I need to do after this, after knowing the plain text and cheaper text is how to know the secret key. Yeah. So that's known plain text. And this is the chosen plain text. Yeah. If known plain text is when, sorry, known plain text, it means if got the plain text. Yeah. And then in the chosen plain text attack, yeah, so cheaper text and plain text is known by if, and the cryptanalysis is how to combine the plain text and cheaper text in order to um, what is it? How to understand the secret key? Yeah, the CPA, chosen plain text attack. But in chosen plain text, if not have all whole plain text, yeah. If only take several part of the plain text, and by taking the chosen plain text, the chosen part of the plain text, if can get the cheaper text, yeah. If also have the cheaper text. So it's actually similar to known plain text, but known plain text, it means the attacker understand or know the whole plain text, but in chosen plain text, yeah, if only know some part of the plain text, not all of the. And this is the chosen cheaper text. It's actually the same as the known cheaper text, yeah, but the attacker only know some of the cheaper text, yeah, not the whole cheaper text. And this is the brute force search or attack, yeah, brute force attack. Yeah, it is always possible to simply try every key. Yeah, so the attacker will try to breach the system by trying all the possibility of the secret key. It is the most basic attack, the proportional to key size, yeah, assuming either know or recognize plain text. So the longer the key size, the longer it the longer it is to be illegally decrypted. Yeah, for example, if the key size here is just 32, so the number of alternative keys is 2 powered by 32. Yeah, so time required to decryption, for each for one decryption, it needs 2.31 millisecond. So it's only need 35.8 minutes to breach the data. Yeah. And if we do decryption at 10 powered by 6, it only needs 2.15 millisecond. Yeah. But if you use 168, for example, in here, the number of alternative key is 3.7 uh, multiplied with 10 powered by 50. So time required to do one single decryption is 5.9 multiplied with 10 powered by 36 years in order uh, to fully do decryption with all the possibility. Yeah. It is very, very long. So key size play parts to prevent the brute force search or attack. So that's it for today. So I hope you can read the material yourself. So maybe you can Google some of it, or maybe you can try the codes. And yeah, I hope you can try the code in C Sharp. Yeah, so you can get the better visualization and better understanding, I hope. So that's it for now. I hope we can meet in the next week, yeah, in the third week. So that's for today. Thank you.